interstellar object 3I/Atlas, which was first detected in 2017, has captivated the scientific community and stargazers alike with its intriguing journey through our solar system. This object, initially categorized as a comet, is of particular interest due to its rare interstellar origin. The comet's path through the solar system offers an unprecedented opportunity for scientists to observe a celestial body that has traveled through interstellar space for billions of years before encountering our solar system. But now, a fresh twist in its story has emerged. Recent observations suggest that the interstellar object may have developed a faint bluish hue, hinting at a possible color change. An unexpected development that has excited astronomers and researchers who have been closely tracking the comet's trajectory and behavior. This potential shift in the comet's color is the third of its kind since its discovery, but interestingly, none of the previous changes have been permanent. What makes this new observation especially noteworthy is the comet's recent rapid brightening, which occurred while it was hidden behind the sun, further adding to the mystery of 3I/Atlas. 3I/Atlas, the third known interstellar object to visit our solar system, was first spotted on its approach in early July. At that time, the comet was hurtling toward the sun at a mind-boggling speed of more than 130,000 miles per hour, 210,000 kilometers per hour, making it one of the fastest-moving objects ever observed within our solar system. What makes this interstellar visitor even more fascinating is that it is potentially the oldest object of its kind ever seen. Experts hypothesize that 3I/Atlas was likely ejected from its home star system, which resides somewhere in the vast frontier of the Milky Way galaxy, a staggering 7 billion years ago. Since its ejection, 3I/Atlas has traveled through the expanse of interstellar space, crossing vast distances before making its current encounter with our sun. This long journey has granted scientists a rare glimpse of an object that has traveled through regions of space untouched by the influences of other stars or planetary systems. As the comet made its way toward the sun, it passed close to Mars in early October, drawing the attention of astronomers who were closely monitoring its trajectory. However, after this close approach to Mars, the comet moved to the opposite side of the sun relative to Earth, effectively placing it out of view for most of the planet's surface. This period of invisibility lasted for several weeks, but some spacecraft positioned in orbit were still able to track the comet's movements, providing valuable data about its behavior. It wasn't until recently, when the comet began to emerge from behind the sun, that Earth-based telescopes were once again able to observe it. The comet's closest point to the sun, known as perihelion, occurred on October 29th. During this time, the comet was at a distance of approximately 130 million miles, 210 million kilometers, from the sun, which is about 1.4 times farther than the distance between Earth and the sun. As it reached perihelion, 3I/Atlas was largely obscured from view, and its brightening was not immediately apparent to most astronomers. However, a pair of researchers analyzing data from spacecraft that were still able to observe the comet revealed a startling finding. The comet had experienced a rapid brightening by several orders of magnitude, an event that could not be fully explained by the comet's proximity to the sun alone. This sudden and unexpected change raised more questions about the physical properties and behavior of 3I/Atlas, prompting further investigation and analysis by scientists. One of the most intriguing aspects of the latest observations is the potential color change that has been noted in the comet. For the first time, researchers have reported that 3I/Atlas appears to be distinctly bluer than the sun. This revelation was especially surprising because the comet had not exhibited this coloration in previous observations, and no one expected it to develop such a hue. According to the scientists involved in the study, the blue coloration is likely the result of specific gases, such as carbon monoxide or ammonia, leaking from the comet's nucleus. These gases could interact with the solar radiation, causing a change in the way light is reflected and transmitted by the comet's surface. The exact cause of this color shift is still under investigation, and while this new discovery is fascinating, it remains uncertain whether the comet will maintain this color or if it is just a temporary phenomenon. To better understand the nature of 3I/Atlas and its behavior, researchers have been examining the comet's chemical composition and structure. Like many comets, 3I/Atlas is made up of a mixture of ice, dust, and gas. Its surface is believed to be covered in a thick layer of volatile compounds that are sensitive to changes in temperature and radiation. As the comet draws closer to the Sun, the heat from the solar radiation causes these volatile compounds to sublimate, releasing gases and dust into space. This process creates the characteristic coma, or cloud of gas and dust, that surrounds a comet's nucleus. The coma is often what makes a comet visible from Earth, as sunlight reflects off the particles in the coma, creating a glowing effect. The sudden brightening of 3I/Atlas, observed just before it disappeared behind the Sun, suggests that something unusual is occurring on the comet's surface. The rapid release of gases could be contributing to the increased brightness, although the exact mechanism behind this phenomenon is still unclear. Some scientists speculate that the brightening could be a result of the comet's surface becoming more reflective as volatile substances are released. Others believe that it could be linked to changes in the comet's structure, such as the breaking apart of material or the exposure of a new layer of ice. Regardless of the cause, the brightening event raises fascinating questions about the dynamics of comets and the complex processes that govern their behavior. As 3I/Atlas continues its journey through the solar system, researchers are closely monitoring its every move. The comet's path will take it past the Sun and then on a trajectory that will eventually lead it away from our solar system, back into the depths of interstellar space. This will likely be the last time 3I/Atlas passes through our solar system, making its study an invaluable opportunity to learn more about the nature of interstellar objects. Although we may not have many opportunities to observe interstellar comets like 3I/Atlas in the future, the data gathered from this encounter will likely provide scientists with important insights into the composition and behavior of objects from outside our solar system. For now, the scientific community is focused on gathering as much information as possible before the comet's departure. As new observations continue to pour in, scientists are hoping to confirm the blue coloration and gain a deeper understanding of the physical processes behind this color change. While the study of interstellar objects is still a relatively new field, 3I/Atlas has already provided a wealth of information that is reshaping our understanding of these mysterious visitors from the stars. The comet's brightening, its potential color shift, and its unexpected behavior are all part of a larger puzzle that researchers are eager to solve. One of the challenges in studying interstellar objects like 3I/Atlas is that they are often moving too quickly and are too distant for detailed observations using traditional methods. However, advancements in telescope technology and spacecraft observation techniques have made it possible for scientists to track these objects with greater precision. The data being collected from spacecraft such as NASA's Hubble Space Telescope and other orbiting observatories have been instrumental in helping researchers piece together the comet story. As the field of interstellar object research continues to grow, 3I/Atlas will undoubtedly remain an important case study for future explorations of objects from outside our solar system. The potential for further color changes in 3I/Atlas also raises interesting questions about the nature of other interstellar objects that may pass through our solar system in the future. Could other interstellar comets or asteroids undergo similar transformations in response to solar radiation? Are these color shifts common among interstellar objects, or is 3I/Atlas unique in this regard? These are questions that researchers will continue to explore as they study the comet's behavior and await the next chapter in its journey. Until then, 3I/Atlas will continue to be a source of fascination and mystery for astronomers and space enthusiasts alike, as it sails back into the unknown reaches of interstellar space, carrying with it the secrets of its ancient, faraway origins.